I'm Jason Grout. I've been working on JupyterLab the last 3-ish years, and this is Matthias, who has been working with Jupyter for many, many years as well. Short note of business, please pull from the repo to update your files. If you git cloned the repo, then just do a git pull to pull in the latest updates. I think we're at commit FA69. So we're going to start out with just a short talk about JupyterLab to sort of orient ourselves, and short demonstration of JupyterLab, and then we'll go into step-by-step walk you through a lot of ways to use JupyterLab, and you'll be able to practice a lot of these things that you're going to see in the initial talk. We plan on covering using JupyterLab and some of the new workflows that are available in JupyterLab over the Jupyter Notebook, and then wrap up with writing your own extension. So we should have like 60, 70, 80 extensions written by the end of today. How many people have used the Jupyter Notebook? Oh, good. Okay. And how many people have used JupyterLab? Oh, fantastic. How many people currently have JupyterLab installed? Well, before the tutorial. Okay, fantastic. Okay, great. How many people have everything installed according to the instructions for the tutorial at this point? Okay, great. During the first exercise, we'll be able to help with any installation problems as well. So let's just start out with a short talk about JupyterLab. And we'll go back to sort of where JupyterLab came from and the genesis of JupyterLab. But first I'll note there's a bunch of names over on the left-hand side of this slide. We have a ton of thanks to the people that have been involved with JupyterLab. It started out as a collaboration between Anaconda, Bloomberg, and Project Jupyter, and since then has blossomed into a work by many, many individuals. Chris Colbert, Steve Sylvester, and Afshin Darian put a ton of work into this early on. And Ian Rose, and I've worked on it, and Brian Granger. Anyway, you can see the names there. There's been a number of people that have worked on this quite heavily, and then it's blossomed since then to include a huge number of people. But let's go back to the Jupyter Notebook. So the Jupyter Notebook has really taken the world by storm, you might say, become a de facto platform for doing data science and doing scientific computation. The idea is we want interactive, browser-based computing environment that lets you explore your data interactively, and it provides a way to have an interactive workflow, but also provides a way to have a document format that makes it very easy to share both code input, code output, as well as narrative, all combined in a single notebook document. One of the fundamental ideas behind Jupyter is that the workflow for doing this sort of thing is language agnostic. And so we have a number of kernels that are for programming languages. So over 100, I think, at current count. Of course, everything's BSD licensed. So here's an example of the Jupyter Notebook. I think everyone's fairly familiar with this based on the show of hands. So where are we today? We still have millions of users. More than we had last year even. We still have millions of notebooks, millions on GitHub alone, and then I'm sure plenty others off of GitHub. We've been enabling reproducible science, so one of the things that we love, one example that we love is the LIGO collaboration. Put all their data up online in Jupyter Notebooks, so you can reproduce one of the most significant physics discoveries in the last century by downloading a Jupyter Notebook and being able to run their analysis on their data. We allow you to, and this is an example of being able to, using the Binder project, to be able to download their notebook. And there's a link there and there at the bottom to actually download the actual scientific data and the actual scientific computations that form the basis of one of the most significant physics discoveries recently. We've been enabling open data journalism. So an example, for example, is BuzzFeed, who put up Jupyter Notebooks for all of their articles, backing up their articles, including, for example, this one on the tennis racket. Interactive textbooks. Riley has a platform based on Jupyter Notebooks for writing interactive textbooks. And then many of you have been using it, of course, throughout your work. One of the things we realized, though, with the Jupyter Notebook is that in the workflows that people have been using, it's more than just the notebook that they need. So we have the notebook, but we also needed a file browser, a terminal, text editor, and of course the notebook. And so what we end up seeing is you need a lot more components, of course, than just the notebook. And so we started putting these into the notebook. And we have a bunch of these components that are sort of completely separate tools. And one of the things, and we call these sort of the building blocks of our workflow, the building blocks of our scientific computation workflow. And one of the ideas behind JupyterLab is to take all of those things and put them into one integrated experience. So the next generation of the web interface for the Jupyter Notebook takes these tools and others, puts them together in an integrated interface, and then there's a ton of possibilities that you have based on this architecture that lets things work together. So here's a screenshot of the JupyterLab. On the left we have a notebook, on the right we have a Python file. The notebook is importing the Python file, and we can work with both together. JupyterLab has lots of buzzwords in it. It satisfies all the checks all the boxes for all the buzzwords. But really beyond the buzzwords, we tried really hard to make a flexible architecture, an extensible architecture, a high-performant architecture. We paid a lot of attention to design early on to try to get the UI and the UX right, and we really tried to make it very clear what the APIs are for extending JupyterLab so it can be a foundation for many different workflows and many different tools built on top of it. Today, we have it's been going on development for about 4 years now. We have about 150 contributors. There's about 60 components, 60 separate components that make up JupyterLab. Last count, we have around 2,600 releases. This is kind of inflated, it feels like, because there's each of these 60 components. Every time we make a release is a release on each of these 60 components. And so one release of JupyterLab involves actually 60 some odd releases of each component separately. But we end up with about 2,600 releases to date, about 13,000 commits. So to put this in perspective, the classic notebook in the repo, the current repo for the classic notebook has about 11,000 commits. So we're on par with the development commit-wise of the classic notebook. And we're currently what we're calling beta, but I think that what you should take away with this is user 1.0. And this came in January or February. So in February, we released what we call JupyterLab Beta, beta series of releases. And what we're saying, this is now ready for users to use. You can imagine it as user 1.0. Use it in your day-to-day work. We've been using it for a long time. We're still stabilizing the extension API, and so we called it beta. So we'd say it's for all users, but for adventurous extension developers, and we'll talk a lot about extension development later today. The plan is for 1.0, which is a stable API for extension developers this year, and eventually the classic notebook will be retired and replaced with JupyterLab. Before I go into a short demo, and we'll mention this later too, but we invite everyone to come to JupyterCon in New York, August 21st through 25th. The 25th is a Saturday. Come and sprint with us. We'll have a code sprint, a contributor sprint on that Saturday. All right, so let's do a quick demo. All right, so can we get a show of hands again? How many people have used JupyterLab more than just like opening it up for the tutorial and making sure that the install worked? Okay, so it looks like maybe a quarter of the people. Okay, fantastic. So this is JupyterLab. Over on the left-hand side, we have a file browser. And then we have a main area that we call the main area, main working area. And on the left, we have what's called the left sidebar. Sometimes we'll have something appear on the right called the right sidebar. In the left sidebar, we have a file browser. So this is a typical file browser that gives you a lot of the operations that you expect. So if you right-click on it, you have a number of file operations that you can do. You have a breadcrumb up at the top, and you can click on the breadcrumb to go back up a directory. In fact, you can use the breadcrumb even more to move things around. So for example, if I wanted to move a file, I can drag it up to here to move it up to the home. Let's put it back into the data directory. At the very top, going in reverse order, we have a refresh button to refresh the file listing, an upload button to upload files into the current directory here. We have a create button, a new folder button, and then a new launcher. The launcher is this tab in the main work area here and allows you to create various items. So going down the left-hand side, we have the Files tab. We have, clicking on the tab it toggles the left sidebar here. The Running tab, which keeps track of what kernels you have running. A command palette with many commands that work throughout the system with keyboard shortcuts noted, etc. A tabs list of all the open tabs that you have. And I installed one of the extra extensions as a table of contents extension, so an extension can add things to the left-hand side. All right, so let's create a new tab using this plus button. So you notice it created a new launcher. It's the same sort of idea as a browser where you create a tab and then you pick what's going to go inside of that tab. We can create a new Python 3 notebook, clicking on Python 3, and then we've got a new notebook. This notebook is a complete rewrite of the classic notebook interface. We tried to maintain a lot of compatibility with the classic notebook, with the keyboard shortcuts and with the mouse interactions, etc. And it uses exactly the same file format as the classic notebook. So the same file format, the same workflow that we all have come used to, but a completely new implementation that allows us to do a few new things. So as an example, here's a notebook from Jake Vanderplas's book. Shift-Enter still works. Wow, I didn't install Seaborn. Okay, I guess we should have put Seaborn as one of the things to install. But you can see down here that it works. Shift-Enter works. I can run by clicking the Run button up at the top at the toolbar, or I have a Run menu where I can have a number of run options. You still have Markdown. You still have math. You still have rich text. You have interactive Jupyter widgets, etc. We've also taken opportunity, since this is a new rewrite, to do a couple of new things, like you have collapsible cells now. So any cell, you can collapse the output. You can collapse the input, or you can collapse both. And you can uncollapse them as well. You can drag cells around. So here I'm dragging the cell to move it. Just grab on the prompt area and drag it. And we have a vastly better extension mechanism for the notebook as well to add things to the notebook. One of the things we can do in JupyterLab is create a new view of a file. So here I'm going to create a new view for this notebook. So this is two notebooks, and I've dragged the tab so that they're side by side. And this is kind of nice. I can do stuff at the top of the notebook, and I can do stuff way down at the bottom of the notebook. I can, in fact, drag cells in between the notebook. So here I'm going to drag this cell up to the very top of the notebook. I'm moving something from the very bottom to the very top of the notebook. In fact, if you scroll in this view here, you'll see that the two views are completely synced up. So you can see two parts of the same file.
So that's a view, but not a copy.
It is a view into the same notebook. That's right. The same underlying model is serving both views. Is there any other questions? Yeah, good question. One of the things we really wanted to do in JupyterLab is make it easy for components to interact with each other. So, for example, one of the things we can do here is right-click, and we'll have some more experience with this in a little bit. We're going to create a new console for this notebook, and what this is it's a console that is tied to the same kernel as the notebook. And so if I press Shift to enter in the notebook, I guess I need to run the cells that, if I press Shift enter into the notebook, and you can see over here, my kernel is displaying the results as I'm executing. The console here is displaying the results as I'm executing in that kernel. And in fact, I can go over here in the console, and I can run things in the console which means I'm running it in the kernel behind the notebook without messing up the notebook. So I can try to explore what was that data frame here again without messing up my notebook. I have two different tools, the console and the notebook, talking to the same underlying kernel and interacting with each other. So here's another notebook demonstrating the Jupyter widgets. Widgets work just great in JupyterLab. So here's my widgets as a classic example that we have in the notebook of the Lorentz attractor. But we also have some new workflows here as well. If I right-click and create a new view for this output, it can pull just this output into a separate tab. I can move it, and you can see that the output inside the notebook is responding exactly along with the output inside the tab. These are really two views of the same output here. But it does allow me to sort of replace the notebook with my tab, and now I have sort of a very simple dashboard-like UI, web app-like UI that's powered by a notebook behind it. So that's a notebook. Same interface you know and love. Same file format that you know and love. Complete rewrite to make it much more extensible, much more powerful, and to work with the other components inside JupyterLab. Okay, let's see the editor. Let me close some of these. In fact, I can go to File, Close All to get back to the initial starting state. Let's see the editor. So here's a Markdown file, for example. And I'd like to see this Markdown file not just as text, but I'd like to see it rendered. So we have the concept of being able to have multiple viewers for the same file. So I'm going to open with a Markdown preview, and I put this over to the side. And notice that I have some code in here as well. So I can also create a console for this editor. And now what we have is a very common workflow you see in other tools where we have a file and we have a console, executable console associated with this file. But this file, unlike many tools, this file is a Markdown file. It's not a code file, but that's fine. A console can be associated with any file. I press Shift-Enter, and it sends that line to the console and executes it. And then go over to the console and see, yep, A is equal to 10. In fact, in Markdown files, there's a logic to go ahead and send the entire fence block over to the console. And so I can work through my Markdown file and see the outputs from my code blocks. So again, I have 3 different tools here working together in one workflow. In fact, these tools are live real-time editing here. Again, we have the same view of the file in the editor and in the preview, so I end up having live preview of my Markdown. So this enables a really fluent workflow of executing code from a script or even a code file. I'm teaching my daughter how to program on a Raspberry Pi. We installed JupyterLab, and this is one of the best ways to teach her how to program. We have a code file on one window in JupyterLab. We have a console in the other window, and it's very easy to experiment with our code file by Shift-Enter to execute it inside the console, play around in the console with it to try to understand the programming concept, and then go back to the Python code file. You can check your library files, et cetera, by hooking them up to a console. You can also, and again, this works with any file. You can highlight a few lines and just execute those lines as well. You can see that one of the nice things about JupyterLab is you can have lots of tools that work together, and pretty soon you find yourself like down into this little corner of this little side over here. So we provided a UI for being able to blow up one of the tabs to the entire tab, to the entire workspace. So if you go to View and Single Document Mode, bam, now I can focus and concentrate on just one single tab. And then this tabs view over here becomes a little more important because I don't have the tabs anymore. We've gotten rid of them to clear our workspace off. But I can still switch between things with this tab view. And I can just exit back out of the Single Document Mode, and there's a keyboard shortcut there as well. All right, a terminal. So let's go ahead and open up a new launcher, and we'll start up a terminal. So this is the full terminal. I can even start up VI. I can exit VI. Whew, I think that's the first time it did it on the first time. Full terminal, you can run Emacs, do whatever you want. We have a number of settings that you can customize, and again, we'll talk a lot more about these during the tutorial. You can see some of these in the settings menu. We have an advanced setting editor that lets you do all sorts of things like keyboard shortcuts and settings on your text editor, etc. In fact, any extension here can provide a settings interface to customize it, and we'll explore that a little more in the tutorial later. One setting that people may like to do right away, though, is the theme. If you prefer a dark theme, we have a dark theme. If you prefer a light theme, we've got a light theme. And this is completely extensible. You can write your own themes and distribute your own themes, install your own themes. Keyboard shortcuts are completely extensible. We'll deal with those a little bit later. And then there's a number of other things that you can customize. One of the things we deal with, of course, a lot in our workflows is lots of different kinds of data files. And so, again, the idea behind JupyterLab is an extensible workflow, an extensible tool, a platform that we can build on. And so we have a number of viewers for different kinds of files. So you have standard things like an image, plus and minus, zoom in and out, the right and left brackets rotate the image, I hits the inverse of the image, so a little bit of a nice image viewer for you. We've got PDF viewer. So this is using the browser PDF viewer. Here's some of the slides, an earlier version of the slides that we saw. We've got even GeoJSON. Let's see, if we go to the museums in Washington, D.C., typically this is what we are dealing with, right? But it's certainly a lot easier to be able to double-click on this and see it as an actual map. So again, this is a plugin. Actually, this plugin was written at SciPy, or at least the initial version of this was written at SciPy in like a couple of hours or polished over a night or something like that. And it gives an indication of how easy it is to write some of these viewers. In fact, by the end of today, we'll write our own viewer for our own file format. We've also got the Vega Lite file. So this is actually a JSON file. So let's see what it looks like in JSON. So we can open this. This is a graphics format, a JSON graphics format that's becoming pretty popular out of University of Washington. And actually, let's open it with the editor as well. So we've got 3 different views of this file here. A sort of JSON tree view, the actual graphics view, and an editor view. And again, all of these are live. I think if I change that to circle, you can see the graph updates, the JSON viewer updates, and of course the editor updates. I can save my file and be on my way. We also have one of the file formats, of course, that we deal with quite a bit is a data grid sort of file format, so CSV or some sort of tabular data format. So this is a brand new CSV viewer that was written specifically for being able to be used in JupyterLab. It's in the underlying library called PhosphorJS that Chris Colbert wrote that forms the basis for JupyterLab as an application. And of course, we've got small CSVs, but it handles even bigger CSVs. So this is a 1.2 million row Excel chokes when it tries to open this thing after taking a long time to try to open it. But JupyterLab opens it just a few seconds to load the 200 megabytes into your browser, and then you can scroll on it as smooth as butter. And in fact, 200 megabytes is sort of small here. In Chrome, and let's see, in Chrome we can handle files up to 800 megabytes or so. In Safari, we're limited basically by the browser's memory, the memory allocation that the browser allows for strings. So in Safari and IE, you can open up a 1.5 gigabyte file. Firefox, you have about a 200 megabyte limit. But any one of these 1.5 gigabyte CSV, as soon as it loads the data over to the browser, you can scroll through it. Just smooth as butter. All right, those are some of the file viewers that come with JupyterLab, but it's an extensible system. It's straightforward to add your own file viewer. So for example, last year at SciPy, we showed off JupyterLab and somebody said, man, I work with FASTA files and doing genomic analysis, and it'd be great if there was a FASTA viewer. And so we sat down in just an hour or two, found a library online that takes FASTA files and renders them. And it just was a couple dozen lines of code to wrap this library, and now we've got a FASTA viewer. So here's a FASTA viewer. this file actually looks like this. And so you can imagine, would you rather work with this, or would you rather work with this? They preferred this. And it's not just the file viewers. The system's extensible enough that it's very easy. This exact same couple of dozen lines of code that made this possible also makes automatically becomes a viewer in the notebook. Looks like something went wrong. I think this is there's a memory issues with the browser when you open up 200 megabyte CSV files and keep them open. So I close out that big CSV file, and you can see here the exact same couple dozen lines of code that took like an hour, 2 hours to write, that wrapped this JavaScript library that had already was available. Not only lets you view the file, but lets you view that data inside the notebook. And again, we'll wrap up today with you writing one of these extensions. As another example, in January we had a workshop in Paris, and somebody said, man, I would love to be able to draw a diagram in JupyterLab. And there's this really cool library called Draw.io, and it's a JavaScript library for doing diagrams. Can we wrap it? And it turns out you can. And amazingly talented person, Wolf Volprich at QuantStack, made a new Draw.io diagramming plugin. And so what we end up with here is a full-featured diagram editor wrapping the Draw.io JavaScript code that lets you do a diagram. So this is a full diagram here. You can edit it, you can save files, you can open up new files. Here's one that I like, for example. But it really is a really nice diagram editor. Took it like maybe a week to try to figure out how to wrap it, interface with the code base, etc. And now you have a full-featured diagram editor in JupyterLab. So really cool ideas. In fact, this particular plugin really opened my eyes to some of the power that you see in JupyterLab. While we were sort of talking about this plugin and things, because of course you can open this file not just with the diagram editor, but with also the actual editor, and these are live models. Martin Brettles over here mentioned, wait a second, so that means that in JupyterLab you can have a diagram editor, that's JavaScript diagram editor, and you can have a text file that are linked, you can have a live updating text file model, and you can have any editor hooked up with a code console, right? So that means like it should be totally possible to have a Python process like being able to manipulate your text file and have it automatically show up in your diagram editor. So now all of a sudden you have Python plugins for Draw.io JavaScript editor, JavaScript diagram editor. And I thought, wait, that is the kind of power that you'll see, I think, with JupyterLab, is once you see how these components can work with and interact and play with each other. Like I had to sit down. I was stunned. Wait, we can have Python plugins for your JavaScript editor? Like, wow. But this is illustrating some of the things that having a platform that is very extensible and allows components to talk to each other and work together. All of a sudden you have the synergy, if you want to use that word, the possibility of things interacting in ways that make everything way more powerful. Okay, so that's some of the exciting new things with JupyterLab. But here's maybe one of the most exciting things with JupyterLab, and that is everything that you see here. Let me open up this file here. This is a JSON file called package.json. This is the packaging format for JavaScript, which we use in JupyterLab. And if I look at the dependencies for JupyterLab, the JupyterLab application, what you'll see here is everything, all the plugins, everything that you see basically on the screen. Here's the CSV viewer. Here's the code mirror editor. So that's the code editor. Here's the cells inside of a notebook in the code editor. Here's the underlying component, keeping track of the documents that are open. Here's the main menus for all the menu system. Here's the PDF extension for viewing PDFs. The notebook somewhere in here. Here's the notebook extension. Here's the theme extension. Every single thing that you see here is a plugin, an extension in JupyterLab. And we really, really worked hard so that any extension you write is just as privileged and just as powerful and just as capable as any of these extensions. It's totally possible for you to completely replace any one of these extensions with your own version of that extension. It's totally possible for you to extend these extensions, to replace them, to package up your own distribution with your own custom spin. I don't like that, particular extension right there. Let me take that out and distribute my own version of JupyterLab with my own custom extensions. We tried to build everything so it's completely extensible. And we're seeing as people start to extend it and adopt this as a platform that the design is really solid here. And I think that's one of the things I'm most excited about JupyterLab. Open source, one of the reasons I love open source is it lets you play with your own tools. It lets you modify and extend your own tools for your own workflow. And so as excited as I am about the plugins that we wrote, I'm even more excited about the plugins you guys are going to write to support and develop your guys' workflow that we hadn't even thought of. But the point is that we're giving you a platform that's a solid platform that you can extend and collaborate on. All right, so 2 resources before we move to the next part that you should know about. One is the JupyterLab documentation. If you haven't seen this, we spent a lot of time really trying to get people familiar with the interface, get people familiar with some of the workflows that are possible in JupyterLab. I highly recommend the JupyterLab documentation. And I also highly recommend the JupyterLab blog post that we put up in February when we went to the beta releases, which were the users ready for users to use on a day-to-day basis. This, again, explains a lot of the philosophy behind JupyterLab and some of the capabilities we're most excited about in JupyterLab. And we'll mention it again later, but seriously consider coming to JupyterCon. It'll be a lot of fun. We'll have more things to announce with JupyterLab by that time, and we'll have a fun time. Okay, Matthias?
Okay, thank you, Jason. Well, welcome everyone who was not there at the beginning. I'm going to redo an introduction about the sticky notes and everything. One word first is that JupyterLab is still highly in development, and especially if you're a new user who have never used JupyterLab, you can have a huge impact. When you're doing exercise and when you're trying to do things here, try to think first, how would I do that? Try to remember how you would do it, then try to do it and try to tell us or give us a note at the end of the tutorial. Where did it not match your expectation? Because we've been working on JupyterLab for a long time, we basically are blinded by how to do things. And especially if you're a new user, you still have this feeling of how things should work. And that's where you can bring us something to do. Okay, so for those who arrived during the presentation, you should have 2 kinds of sticky notes, red one and green ones. When something is wrong, if you don't have an installation problem, if you don't understand something, stick the reddish sticky note on your on your screen, so that we can know that something is wrong and we can come and see you. And if everything is fine, put the green sticky note so we can move forward. If you have any questions, we have a helper in the room. If helpers can stand up or raise their hand so that you can see that you have a helper near you. So we have 3 helpers, 2 in the back here, 1 in the front, and also Jason speaking there. There's been a couple of installation problems on Windows. Apparently, IPY volume is not working. So if you can't create the environment, just remove IPY volume from the thing that you need to install, and we can figure the rest. Oops, I forgot to activate. What's the name already? Activate and JupyterLab. So just to remind you, when you want to start JupyterLab, you just get in your conda environment and you do JupyterLab. If you have already Jupyter Notebook running, you just change the URL here to lab, and you will be able to see lab. Like right now, if I do that, I have the normal notebook running at the same time. That's just to tell you that you don't have to have two servers running in parallel. And so what we can do now is try to go through So one of the first exercises, take our time. You don't have to exactly follow the instructions. If you have a workflow that you want, which is slightly different than what we are doing in exercise 1, try to go through that and see how JupyterLab matched your expectation. Okay, so let's go to exercise 1. And now you have exercise 1.md, which is a Markdown file. And in this Markdown file, there is a number of things to try to do. See if you can get them to work. Try to find different way of doing things. Try to find different way of breaking things. No, yeah. You can break things. And you should try to find a couple of bugs that are fixed now in the next release, which is in RC, that we'll see later today. And so the first task is relatively easy. It's remove the sticky note from your screen. So I'm going to do that, and let's give you like a couple of minutes to work through the example. And so like remove the sticky note. And if something is not intuitive, so for example, the sticky note was hard to remove, you can grab a pen here or ask us for one and write on the red sticky note. It was hard to remove the red sticky note. Okay, the first thing is I'm just going to go through the first one and then let you do the rest. Try to view this Markdown file as a render Markdown. And so the way I would do that is right-click here and say Show Markdown Preview. And now I have the Markdown Preview. One thing I could have tried is to click on the tab, and you see here that something that surprised me when I was preparing the tutorial is here I don't have create a preview. So that's something that I would write on the red sticky note. Well, I was expecting to right-click on the tab and have a new Markdown preview, but it was not there. So you see, you can be surprised by JupyterLab. And one other here is you can do open with Markdown preview, and then you have your preview, which is slightly nicer to see the Markdown file. And now I will give you 10 minutes to go through that and ask questions, and then we can do a pseudo correction and have the first break. I'm going to go slowly. With time maybe faster through what was to be done for exercise 1, and make some comments for the question I had, and then we can move on. So to create a new notebook, we're going to create a new launcher, and in the launcher we're going to say, hey, I want a notebook here. So now I have a notebook. If I don't need the sidebar here anymore because I'm on a really narrow screen and I'm not on my 42-inch at my work, I can click again here and it will hide the sidebar. So either you can switch which tools you have on the side here, or you can click a second time and it will hide things. And now I can drag things around. So you have to get used to exactly how to move things around. The blue rectangle gives you an idea of where you're going to have to drop things. So to really become efficient, I suggest you try to learn keyboard shortcuts. If I came to your machine, you probably saw me touching your keyboard and the layout completely changing. There is one nice thing in JupyterLab, that all the commands that you can do everywhere are accessible in the command palette here. And you can search for anything. So for example, I want to make this cell markdown. I'm going to look for markdown here. And you can see that it says change to markdown cell type. And on the right side, there is M. And on the right side here, is basically this column is a shortcut you can use to do this command without having to search for it. When you have modifiers, this modifier will appear hopefully with the normal symbol. When you're on macOS, it will have the weird thing, which is the apple or the caret to take control. And also, I'm going to look at code and change code cell type to code. It's Y. And so now, if I hide this command here, I just learned that if I want to change this cell to a markdown cell, I just need to press M. You saw that the prompt disappeared. And if I want to make it a code cell, I can press Y. I'm going to change that a couple of times so we can see the prompt blinking. And one thing that you may notice is that this is the thing above here, say, change between code and Markdown, and this is the other quick way to change cells from code to Markdown, is go here from code to Markdown. If you're not familiar with the notebook interface, it's a modal interface. Maybe more modal than other editors you've used, but most software are modal. So when you have several cells, you may want to either manipulate the cells themselves or edit what is in the cells. And so what you can see here is that when I'm pressing up and down, you can't see me pressing, but you can guess, I'm actually moving which cell is selected. And if I want to edit a specific cell, I'm going to press Enter, and I will go into that cell, and I can type Markdown. With bold, bold is 2-star, and italic is, for example, underline. And when I want this Markdown cell to be rendered, I'm going to do the same as if I'm executing a Python code cell that we'll see later in this example. I'm going to press Shift-Enter. And when I do Shift-Enter, I'm going to select the next cell and render the cell above. So you can do math in line with single dollars and display math with $2. So you've probably seen the difference. One is rendered in line. So this is inline, and this is displayed, YED, and you see that display will be on its online, centered. And if you want to have some code snippets that are non-executable, either you can put them in between backtick for I in range 10. Print I. And so that will render in a Markdown cell, and you can even put a language here. The other thing you can do when you want to edit a cell is double click on it, and it will switch to edit mode. So now I had code cell below. Create code cell and evaluate it, printing hello SciPy. So print hello SciPy. So I can do Shift-Enter to execute and select next. It asks you after what you can do. So you can do Shift-Enter to execute and select next. Control-Enter to keep executing the same cell. So if I do, for example, A create range 10, and I do next A, every time I do, oops, not an iterator, I need to iterate on it. I don't know my Python well. Every time I will press Control-Enter, it will go to the next value, and at 10 it will raise a stop iteration error. So if you want to iterate on something, you can use Control-Enter. And if you want to execute something and add a cell, we have a command shortcut which is Alt-Enter, which is execute and insert below. So now if I press Alt-Enter, it will execute this cell again. So print hi, but will insert a cell just in between. So Alt-Enter, and now I have a new cell to add something before continuing my analysis. I personally also know the keyboard shortcut to add the cell above and below. So A is for insert a cell above. So A, I will have a cell above. So here, I'm going to do it right here. If I do A, I insert cell above, and if I do B, I insert a cell below. It's not confusing, it's above and below and not before and after. And now you don't know which one is which. I'm now going to import pandas. So what you can do is, oh, that's my machine, so it's something weird. Yeah, it doesn't work. Yeah, I have some weird thing on my machine. I have Jedi installed because I'm working on tab completion. You should, when you press tab, be able to have a tab completion of well, of what you're typing, of your modules, of your methods, of everything. Depending on exactly which version of software we have, we're working on that. You may even have in the tab completion have type inference. So you will have in front of each possibility, you will have a small square with a color and a letter. And that will tell you whether something is a class or is an object or is a method. that is relatively nice. And that's weird. I don't know why it doesn't run on my machine. Why? Oh, F capital. So if you put a question mark, it will give you some extra information that's based on the IPython kernel. If you put 2 question marks, I invite you to look at the IPython in-depth tutorial, which has been given at SciPy a couple of years ago. Nothing in IPython has changed. You can use the same shortcut everywhere. 2 question mark will actually try to give you the source of something. And if you do Shift-Enter just after an opening parenthesis, you can have a quick help that will be dismissed immediately when you start typing. In JupyterLab, something which is new is the inspector that I just opened here by pressing Command I on Macs. You can go here and search for inspector here, and it says that the shortcut is Command I. I don't know the shortcut on Windows. What the inspector will do is it will automatically pull the documentation for the things you're typing. So if you do pandas up, as soon as I'm in pandas, it will show me the documentation on the side here. You can see that the documentation could be rendered way nicer. We still haven't implemented that. Maybe you can do that at the sprint. Data frame, I have the documentation about the data frame. What else there was to do? Question mark, tab. Okay. So one of the exercises was to use read CSV data iris.csv, and that's my data frame. And you can see that your data frame is nicely rendered as HTML here. Slight difference between returning something as the last expression, expression of a cell. So here you have out 29. If you do display, you won't have out 29. It's the same difference as having some as print, except display is able to display rich representation. So print can only show text, display can show HTML, images, etc. If you do something magic, that's if you do matplotlib inline, now you can have directly inline plots in the notebook. It told matplotlib how to hook some things. And you can, let's do plot.scatter sepal length versus sepal with no key error length, GTH, big finger. So now I have my flowers here, and try to color that by species, and you will see that it's not happy because the species is not a categorical yet, and we'll try to fix that in an exercise further. So more advanced, what you're going to see just after is that you can drag things. Some of you has question about that. But what we can do now is take a short break because it's already 9:07, and we can go through that quickly after the break and take questions and resume. Don't forget to write something bad on the red sticky note, stick it outside the door. So something good on the green one, if you want, and take new sticky notes when you're coming. Go get coffee. Yeah, be back in 10 minutes. The break is supposed to be until 9:05, which is already passed. So let's do 5–10 minutes. Or here, it's fine. Like wherever we can find them relatively easily. Thank you. Okay, 2 more minutes. Still a couple of people grabbing coffee, so we can. So we had some really good questions and comments. I saw on the sticky note that a couple of people made the same suggestion. Let's see if it's again the same suggestion. That you will be able to do by on your own at the end of the tutorial. So, for example, something that came across a number of times in the sticky notes were, hey, when I want to rename my file or something like that, I want to double-click on the tab. Well, we're going to open an issue and see if we can get that to work. So we're about on time. Let's try to go again through what were the more advanced notebook tips that you can do. So you can move a lot of things by dragging. So you can drag both output and input. So if you want to rearrange a notebook, you can. Oops, I did something else. You can grab a cell and move it to another spot. Something that you can do, especially if you have a really long notebook, is to make a new view from notebook, as Jason showed earlier. So the way I know to do that, which might not be the only way, is to right-click on the tab and make a new view. And so everything is backed by a real-time model. So every change you make on one side is reflected on the other side. One thing we haven't done yet, but which is coming, we're working on it, we need help, we need money, we need lots of things, is to actually back that by actually something like Google Drive and real-time collaboration, so that you can not only have real-time collaboration on the same machine, but you could, for example, right-click on something and say share with this person, and then it's shared across computers. So that's coming. It's not there yet. And so because it's actually the same view on both sides, let's say I want to move this matplotlib inline from the bottom of my notebook to the top of my notebook. It's relatively hard to grab that and scroll at the same time. I can do that, but I can also drag it in between view, and now it's there, and I can scroll up here and it's here. So if you want to drag things, you can drag things between view of the same notebook, which will make some workflow easier. When you have something like that, show a plot, or you have a question here.
That was copied. When you dragged it across, it was copied instead of moved.
It was copied instead of moved.
So it's in all three places now. You dragged it twice and it's in all three places.
Yeah, that might be a bug on this version. It should move it. Jason, is it a bug?
Yeah, when you go between tabs, it's always copied.
Okay, so that's my bad.
Maybe it shouldn't be. I don't know. Like we could make a decision.
It used to be moved at some point. Then someone said it was a bug, and then we made it copied, and then someone else said it's a bug, and now we need to discuss. Right, you know, when you hold control, Emacs hits really fast, and there is an KCD about that. Well, then just learn the shortcut to delete something. Command, is it delete? Delete cells is D, which means press D twice, because we don't want you to delete something by mistake. So if you go on this cell, well, let's look if it deletes in both at the same time. I'm going to go here, I'm going to press D twice, and it disappeared. Ta-da. Is there undo for delete?
Undo cell operation.
Oh, undo cell operation. Where? There is one? Oh yeah, I'm just tired. Yeah, it's there.
Can you copy between two different notebooks, or do you use application?
Well, file, new, notebook, grab print high, and put it here. Seems to work. There is also, I don't know how to do that, but you can have comments. We have a Google plugin, but Google deprecated their API, so even if it works, we can't release it. It's complicated. You basically can have a Slack channel on the side of the notebook and say, hey, this cell is wrong. I believe what you mean is blah, 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 with a long equation, and you can drag from the command that person made into the notebook to fix your notebook. So it works between any plugin. As long as you register your plugin with the right hooks into JupyterLab, it should just work. Emphasis on should. Using the view menu or click the blue bar to collapse and expand input and output. So when you have a long output like that, probably like a student that did a for loop with 10,000 print I, you can click on the blue bar here and you see that it collapsed the thing. Now you have ... and you can click it to reshow it. Or if you have a really long input, you can also collapse the input cell. And here the output is still there. If you collapse the output, it completely disappears. And you can re-click on the ellipses to reshow the input and re-click on the output to expand it. If there is some graph you're working on and you want to iterate on that, you can create new view for output in a context menu, which is create new view for output here. I'm going to put this view there. And so now I have always this graph which is shown here. And if now I want to have, let's do df head to see what we have available. We have petal length. So let's change petal. And because it's basically, again, a shared model, when I shift-enter there or control-enter to not select the next cell, this graph should update. And it does. So what you can do is actually have different views, not only on full notebooks, but of specific graph. And so again, everything you do here with the mouse, which is relatively slow, and you need to point the right pixel, what you can do here is search for the command you want to do under notebook cell operation, and on the side here, you can see the shortcuts that are bound to that. So you can actually press those keys to do the action and gain efficiency. So what else? Collapsible drag things, enable scrolling output. So for really long output, you don't have to only have a hidden output, but you can enable scrolling. So for I in range 100, print I, or let's be more I squared is. It's really hard. And that's quite long. So one of the other things you can do is to right-click and enable scrolling for output. So now you basically have all that in a more compact way, and you don't have to scroll for hours to figure out what is on the next cell, creating new view. So one of the slight difference that you will see in between JupyterLab Notebook and normal notebook is that JavaScript output is disabled by default. So if you remember and if you've played with normal notebook, you've learned that object can have several representation, HTML, PNG, GIF, depending on how you pronounce it. But it's spelled the same, and also JavaScript, which was used for things like widgets and so on and so forth. One of the differences is that now in JupyterLab, you may have several notebooks on the page, and there are also security issues with JavaScript. So right now, if you have a representation that displays JavaScript, it won't be shown in JupyterLab, but will still be shown in Notebook. Speaking of normal notebook, if you have something that does work in normal notebook but not yet in JupyterLab, of course you need to open a bug and say, hey, this doesn't work. And we may tell you, no, we won't make it to work, but we'll try our best. You may want to basically go back temporarily to the normal notebook. So what you can do is go to help here and do launch classic notebook. It's actually not launching it, it's just opening a new tab that points to it. And you can find exactly the same notebooks that are currently running. And let's do, hey, I modified that from classic notebook. save, close, go to JupyterLab and refresh. And hey, I modify that from Classic Notebook. So you can access things from the Classic Notebook as well. The only difference is that it's like when you open a file with two editors, it's last save wins. So don't have JupyterLab really open and saving things while you have Classic Notebook. But what you can do is open Classic Notebook, change something, see how it affects something, save, and then go to JupyterLab and refresh. So if you have something that don't work in JupyterLab, that's a way of bridging the gap. So we've seen some workflows that are really similar to what you can do in normal notebook. But because JupyterLab is everything in a single UI, you can do way more things. Especially, you can attach kernel to any kind of documents. You don't need to have a notebook to have a kernel. You may have seen in the launcher here that we have. I have many kernels. We have console. So for those of you who use a Qt console, it's something which is similar, but is in a web browser. It's a more linear. You can't edit what is before. It's like a terminal, but can display things. And so you can execute code. You can't do Markdown. And so these things are basically just executing code. And what you can do is actually attach such a console to any document. And with finding a shortcut or using a command, you can send code to this document to the console and execute code. So one of the things you can do, I think I've put it here, is say you have a Markdown file because you like Markdown file and you want to try to execute the code which is in there. And you may have been used to actually create a new terminal, and you put it on the side here. I prefer white themes. And you used to be able to open IPython here, which takes some time, and say, well, okay, I'm going to try that. I'm going to copy paste here and enter, and yes, it works, and keep on going. So that's one way of doing it. What you can do now is actually right-click and create console for editor. And so when you create a console, it will ask you to either create a kernel or attach to an existing kernel. So here you have new kernels, or you can use already running kernels. So let's attach to this one. I don't know which this one is. I probably should name my notebook. And let's see. No, pandas is not. Who else? So A, df, I, and pandas that are defined. So df is my data frame. So I can actually attach a console that I will put on the side here in small. And now if I want to execute code from this Markdown document, the only thing I have to do is to, for example, select the piece of code I want to run, press Shift-Enter, and it will be sent to the console on the side here. So here it has no side effect. If you are in a fence block that have code, it will automatically detect that that's what you want to send to the console. So you just need to be on this line and press Shift-Enter, and it will send that and execute. And so now I can just quickly verify that my document is doing the right thing by pressing Shift-Enter and see how the results are appearing on the Qt console. So that's kind of convenient. And most of the time when you're starting to build bigger software, you need to move things from a notebook or from a Markdown file or from anything to a library that you can import and reuse. But it can be quite cumbersome because you need to restart the kernel every time. So you can do the same here if you want. If you want to have your data frame here, you can press. Oops. You can press 00 twice to restart and click restart. And now df is not defined, so you actually need to re-execute everything. So import pandas, read that, matplotlib inline, and scatter. And so when you're developing a library, you might want to automatically reload your Python code. That's an IPython specific feature that we have been having for quite some time, which is called auto reload. And so if you do load extension auto reload, and then you say auto reload 1, now everything you import with a import something will automatically be reloaded every time you try to be reloaded, because you can't always really reload things. Try to be reloaded every time you execute code. So now I have this Python library file here that basically just take my data frame and mutate it to make my last column, which is which species my flower is, a categorical value, so that if it's a categorical value, I should be able to basically do scatter with color, and so have each species be a different color in my scatter plot. And so right now I'm going to make a mistake in my library, so it won't work. So I'm going to no module lib pwd. Let's just kill that and restart. Create console for editor, put it on the side, and rerun thing. Import pandas, load my thing, plot lib inline, scatter. No module lib y. I don't know why it's doing that. Let's do cd exercise 2. No. In exercise 1. Oh. Exercise 2. Okay. So now I'm in exercise 2. I should be able to do that. Yeah, it works. And if I try to read my CSV and plot something, it will throw an error because I have an error in my library file. So I'm not going to go through the error. But now the only thing I can do is fix my I don't have to restart my kernel, and hopefully everything works. Now my Python file has been reloaded automatically in my environment. I haven't lost any of my current variable. And I can directly run this, and now I have my my nice graph with a different species of flowers. And so obviously I can attach a Markdown file like this one, but I can attach a console to any Python file. So if you want to try snippets of code in your Python file while you're developing a library, you can do the same. You can create console for editor, Python 3. I'm going to put all the console on the same tab. Make the type small. So my console 4 is attached to libpy. And I can check that categorical is not defined. And now, if I'm going to this line and press Shift-Enter, it sends this line here, and now I can have categorical here. So if you're like me and you like to really iterate over something quickly to figure out how it works, you can now attach a Python file. Actually, I probably shouldn't need to do that to have more space. You can iterate quickly over this code and see how it works attached to a kernel. So the other thing you can do, of course, is to open a terminal and have something that watch. But it's up to you to have the workflow you like. You can, of course, now also, I guess, attach multiple notebooks to the same kernel. I don't remember how to do that, by the way. Change kernel, and I can attach notebook B to kernel of notebook A. And so now, if in notebook A I do A equal, this is new. Now in notebook B I also have this is new. So if you have two notebooks workflows that are doing analysis on two same data sets, you can now attach two notebooks to the same kernel. And I have one question here. So the question was, you have your IPython set to automatically load the auto-reload extension. Will it automatically work in JupyterLab? So the way Jupyter works is it's not really aware of the kernel-specific configuration. And IPython is just a specific kernel for JupyterLab. So you may have several Python kernel for JupyterLab that each have a different configuration. If your default configuration is not changed, usually the default configuration for IPython will affect the normal kernel of JupyterLab. And so if IPython is set to automatically load an extension, then JupyterLab will see the same extension. But it's up to you, and it's up to how you configure your specific kernels. And again, kernels may not only be languages, they may be different Conda environments, they may be different machines. So for example, if you see my JupyterLab launcher here, you see that I have many kernels, but I have, for example, two Julia kernels with different version, and this one is a specific project I'm working on, which is launching a kernel in a specific Conda environment with specific configuration. And it's up to you to define what these are. What you can have here is, for example, a kernel that runs something on a cluster. It will take some time, you click on it, but it will actually SSH and launch a cluster remote. And again, the auto-reload extension is not enabled by default because it cannot always reload everything. It's a best effort, and so we prefer to make it opt-in because otherwise it can be surprising result for people. Next section was. So now we have exercise 2. We have 2 minutes to start, so we can go slowly. So you can go again in the exercise 2 folder. You have exercise 2.md here that you can again try to not new view. What I want is a markdown preview, and you have a number of things to try to do to try to attach multiple kernel to multiple documents to the same kernel, and also try to learn about single document mode, because when you may want to have many documents on a single document, but you may want to have a distraction-free environment to work, and that's nice to have. So let's work 15 minutes on that, slightly more, and after we will do a correction. And you can again go to the break. I think the snacks are removed at 10:10. So you have 25 minutes to get snacks. Okay, so I think almost everyone is ready. So we're going to restart 5 minutes early and go into customizing JupyterLab. Based on what I've seen around, there was one thing which was unclear, is that you don't need to copy-paste between a Markdown file and a console. So if I close all of that, remove a notebook has no name, and create console for editor here, I don't have to copy that and paste it here. The only thing that I have to do is to bring my cursor in the fence block and press Shift-Enter, and it does send things by itself. You can also select just one word and press Shift-Enter, and it just sends this word. And if it's a full block, it sends a full block. So basically, you can iterate directly. And if you want to send non-Python code, you can also, but you will get a syntax error. Syntax error are not always obvious, especially if you have beginners. Some people have started to look in advance into how to do shortcuts and everything, which we're going to do now. And we even had feedback on things like, hey, I want Emacs key binding for my editor because I'm an Emacs person. First thing, you're wrong. No, I'm just kidding. I'm just kidding. I just have one figure per hand, so I can't use Emacs. I actually have a real reason that I used to use a French keyboard, and the shortcut of Emacs would basically prevent me from typing accents on the French keyboard. So I learned Vim, and now I'm a Vim user. I'm sorry. But if you want to have Emacs shortcuts, you can go to settings here. You can go to text editor key map and select Emacs, Vim, or Sublime. The JavaScript library we use for editing code is called CodeMirror, and have that already built in. You don't have to use CodeMirror if you're using to something else. You can actually switch all the text editor for Monaco, I believe, which is behind VS Code or things like that, and have different features. And so one of the things which might be hard at the setting level in JupyterLab is that there are JupyterLab level settings, and then you will have settings for a specific underlying library we use, for which we don't expose UI. You're basically, well, there is an underlying library, we just pass configuration down the way it is. We cannot really make UI for you to configure that. Here for CodeMirror, we've done menu for some settings, like for example, the keyboard shortcuts, or the theme if you prefer to have a dark theme. And so that's where here you can see that you can separately change the editor themes to dark, or change the JupyterLab themes to dark, which is here. And you see that it refreshed, and now I have everything dark. But I can have, for example, the editor themes to still be the so interact in a weird manner. You can have the editor which is clear and the JupyterLab which is dark, because we just don't really have a cross integration with underlying library. So for those of you who say, hey, I want Emacs key binding, well, you already have them here in setting key map. Okay, so that's how to change editor settings. For some reason, something that I just realized yesterday, the color settings for the editor are in settings. But if I create a new terminal, for example, which is clear here, and you want it to be dark, it's in view. Wait, no, it's not in view. Or use dark terminal theme. And so the terminal also you can switch from light to dark. So depending on whether you like to be awake late at night or sleeping during the day, you can change your theme. So if you look around in the menu, you will see that there is a number of convenient way of changing settings for different components. But as I told you, there is a large number of underlying library where we can't write the code for every option, and especially since some options are really complicated to edit. So what we have is the advanced settings editor. You can go there. And I'm going to switch back to light because I can't read dark. And the advanced setting editor allow you to edit JSON files that are powering the configuration of everything under JupyterLab. And so if you want to do any advanced configuration of things you don't find in menus, you will have to go there and write some JSON by hand. It could be easier to edit. We just haven't had the time to write a better editor or something that that provide more UI elements. So we've tried to do some classifications. So CodeMirror is the underlying library that power text editing. So if you're using default JupyterLab and you want to specify how CodeMirror handles things, you can go look at the CodeMirror documentation, look at the options that are available, copy and paste them there, and they will be passed down to CodeMirror. So for example, this handles automatically closing brackets when you press either a curly bracket, a square bracket, or an open bracket, whether you highlight brackets, some option about the theme, some option about tab completion in CodeMirror. So that you would have to go to this library in particular, look there, see what options are available, and change them here. So for example, we expose key map, like if you change the key map here to Emacs, you should see on the side here, that's the default value. You see on the right, that the key map has now changed to Emacs. And if I change the key map to Vim, it's changed to Vim. And if I hopefully do Emacs here, and I go to settings and key map, it's changed back to Emacs. I'm going to put back default. And for code mirror, yes, question?
So if we close JupyterLab and open it again, will my next session also be Emacs and I change it, or do I have to reset whatever?
No, so that's saved on user disk. So if you close your JupyterLab and reopen, it will be saved. I can for example just refresh the page. You see that it kept the layout for things. A couple of versions ago, it would just trash the layout and you have to reopen everything. But the configuration stays. So that's I don't remember. Is that JSON? Is that stored on disk or on local storage?
Yes.
So that's stored on disk. There is other things that are stored in your browser. So if you change browser, you won't have this configuration, but that's stored on disk. So it's per machine, per user. Key map, for example, in code mirror, may be things more complicated than strings, that you can have your own key bindings. So you can develop your own key map. If, for example, you don't have an English keyboard, because most of us have English keyboards, so most of the default shortcuts are planned for QWERTY keyboard. You may want to have a JSON blob here. And so you have here a configuration for every component of JupyterLab: global text editor, notebook, keyboard shortcuts, and document manager. One of the parts I'm going to focus on is keyboard shortcuts, because if you want to be efficient with JupyterLab, you basically want to customize your keyboard shortcut to not have to reach for the mouse and find in menu. I forgot to remove what I was going to do, so you have a spoiler here. So what you see here is system default. And the way this works is you can define a number of commands that can be executed in some contexts, and then attach them to a specific keyword. And so, for example, if you want to switch to previous or next tab, you see that there is a command here in the system default called application activate next tab, which does application activate next tab. And the shortcut that will trigger that is Control-Shift square bracket. So if I do Control-Shift square bracket, it selects next tab. And this is available when basically what I have in focus is body. We are not going to focus too much on what these selectors means, but you will get used to that by copy and pasting. It's basically telling you when I have this in focus, I want these shortcuts to be available. So that where you're in a Markdown file, Shift-Enter executes the current fence block, but while you're in a console, Shift-Enter executes what is in the input prompt, and when you're in a notebook, Shift-Enter will render a Markdown Markdown cells. And so, for example, if you want to have custom keyboard shortcut, like restart kernel, or is already bound to 0, 0, 0, which is pressing 0 twice. So if you want to have something twice, you will basically, in keys here, you would put 2 entries, and you need to do each entries in sequence for the keyboard shortcut to be triggered. And so what you would do in user override, you will write something that will be merged with the default value. You say what you want to do. For example, hide cell outputs. I give it a new name, like I call it -2. You tell it what to do. Well, I want my current notebook to hide cell outputs, and I bind it to a specific key, which here is minus. When you write a shortcut, you don't give the actual symbol you want the key. So for example, on my keyboard, if I want plus, I wouldn't write plus here, I would do shift equal, because plus is when you press shift and you press equal. Shift is a modifier. And now that you have that, it should automatically apply to your current session. So if I do for I in range 10, print I, and now if I do minus, it should collapse the output. And if I go to setting here, let me just hide that for you to see better. If I do shift equal, which is plus, it should notebook show cells outputs. So it should expand what I have. And so if I'm here, and I'm doing Shift plus, it expands things. And so right now, that's how you go to advanced configuration of JupyterLab. You have to figure out what is the command you want to run, what is the selector you want to run. Usually what you go is you go into system default and you look for something which is similar to what you want to do, and you copy and paste the selector. We're not going to go too much into detail into what it is. And then you bind a specific shortcut. And give it a name so that someone else can use it if they want to. And with that, you should be able to customize JupyterLab in the way you like. And one thing that you will see is that this system, well, this is not really JSON because there is comments. So the thing that we have here will automatically strip comments. One thing that I saw earlier today that I was pointed to is what you have to write as a user is valid JSON. What is on system default is not valid JSON. So if you copy and paste, don't forget to add trailing commas at the end of each section. So here, if I were to copy paste that here, I would have to put a comma at the end and put a comma here. Okay, and that's going to be stored on disk on your computer, and now you have custom keyboard shortcuts. And that's where we start the next exercise, where we're going to try to change keyboard shortcuts that already exist. So that's in exercise 3, I believe. Well, you remove your sticky notes because everything is not fine now. You need to write JSON, and so you will have missing commas and everything and missing quotes. And try to not look at what I did on my computer and redo the same. Try to bind custom keyboard shortcut to for the notebook. Try to, for example, see if you can do a restart kernel and run all. Yes, you might not be able to do exactly because you may need a Jupyter plugin that you will see later with JSON. But try to, for example, bind a keyboard shortcut to run all cells to be able to quickly check that the notebook is reproducible. And I'll give you something like 15 minutes. And after we'll switch back to JSON that will show you how to do extension. And then you will write your own extensions that congratulate you for mastering JupyterLab.
All right, so I wanted to first give a short overview of what these extensions are and how extensions basically work in JupyterLab. But actually, let me say one thing that we've noticed people have questions about before, and we tried to emphasize in the documentation, but you might come up with as well, and that is when you're, oh, whoops, maybe that's not the right JupyterLab. I'll close that one down. This one probably works better. Okay, so when you're in the notebook, sometimes you have an image or whatever, or sometimes you want to copy some text and stuff, especially like opening images and stuff. And if you right-click to like view an image or copy an image or something like that, you get the notebook menu. And our convention is if you shift right-click, then we give you the browser menu. So if you want to ever get to the browser menu to actually do like a copy or a view link or whatever, shift right-click. Okay, right-click gives you the sort of notebook context menu or the JupyterLab context menu, if there is one, and shift right-click is our convention for passing through to the browser context menu. So hopefully that saves you some frustration in the future. Okay.
That was really helpful for terminals.
Oh yes.
Trying to like add things or pull things from terminals. It was super frustrating until I figured that out.
Yes, useful for terminals too. Yes, thank you for pointing that out. Yeah, shift right click is sort of our convention.
Also, like Control Shift E will do like
There's various shortcuts for pasting into terminals that people have noted on Windows. Is Shift Insert, I think, and stuff like this. Yeah, so there's various browser like shortcuts for pasting, and they work in the terminal as well. Yep. Shift right click always gives you the browser context menu. It should always file a bug if it doesn't give you the browser context menu, because that's our convention sort of across JupyterLab. Okay, so extensions. So first, I want to just briefly talk about what extensions are, how they're installed. You notice there was a bunch of like weird JavaScript commands that were run when you were installing extensions, and how to manage extensions. So JupyterLab is based on the concept of extensions, like we said before. If you go to the JupyterLab repo, you can see the actual extensions. So if you go into, where is it? I guess you can probably go into, let's see, JupyterLab package, that's where the Python stuff is. Staging, the staging directory is where the actual JavaScript application is built. And this package JSON right here lists the actual JavaScript packages that go into JupyterLab. And these are the JavaScript packages I mentioned at the very, very start. So each one of these is what's called an NPM package. NPM is the JavaScript packaging solution that's out there. It's widely popular. And so every extension for JupyterLab is an NPM package. So for example, here's some NPM packages that we were looking up just a few minutes ago to see if there's a way to get restructured text preview, et cetera. So npmjs.com is the repository for NPM packages. So basically, if you have a JupyterLab package, it needs to be packaged up in the standard JavaScript way, which is an NPM package. And that's what you were installing when you were doing JupyterLab extension install. So when you do Jupyter Lab extension list, it gives you a list of all the custom packages. So it omits the core packages and gives you a list of just the custom packages that you've installed. And these are the packages that you've installed with Jupyter Lab extension install. When you do Jupyter Lab extension install and then give it a name, that name is the NPM package name. That's why it was sometimes a weird name that had like @JupyterLab / something or other. That was a NPM package name, a JavaScript package name. Lab extension list shows you the NPM packages that were installed and tells you if they were enabled. We have the concept of even if something is installed, it can be disabled or enabled. And whether the files look like they're okay, so it looks like your package is installed correctly. I guess a caveat on that, not all NPM packages are JupyterLab extensions, but all JupyterLab extensions are NPM packages. Essentially, JupyterLab extension is an NPM package with specific metadata in the package.json metadata file that says I'm a JupyterLab extension, and then we know where to go find the code and load it into JupyterLab. Question?
Why does some have an X?
Good question. In NPM, we have the concept of a package name, but we also have the concept of an organization, and the @ signifies an organization. So in NPM package terminology, this particular package lives in the Jupyter Widgets organization, and the package name is JupyterLab Manager. So it's just a convention for NPM package names. You'll notice that a lot of packages, for example, this one, lives in the JupyterLab organization. So we developed this one, the Jupyter Widgets. So I'm part of the Jupyter Widgets organization. So the Jupyter Widgets organization owns this JupyterLab Manager package, et cetera. Other questions? How many people have dealt with JavaScript in general? Okay, how many people have dealt with NPM specifically? Okay, well, get ready, because that's one of the things we're going to do. Okay, so a little bit more about the extensions. So you can install or uninstall. You can also enable or disable. So JupyterLab extension -h gives you some examples. Here it is. Enable or disable. So you can enable or disable any package. Disabling a package basically loads the JavaScript up, but then JupyterLab doesn't call into that package and load that extension. So you can have a lot of extensions installed and actually loaded on the page, but without them actually being activated inside of JupyterLab. I guess there's a check command too to do some sanity checks. So what happens when you actually install a package is that if you type JupyterLab path, it gives a bunch of paths, and the application directory is essentially the equivalent of this staging directory. And this is where the JavaScript is actually built. And if you go to that application path, which I've done here, and look at it, you'll notice a couple of subdirectories. Now, this is all details about the build process, but it's probably useful to have an idea about this, even if you don't know like all the specifics, just to understand better like what JupyterLab is doing when you install an extension. If you go into this extensions directory, you'll notice that here's all the extensions that I've installed. This is how JupyterLab keeps track of what extensions you've installed. And if you go into the staging directory, this is where JupyterLab is actually built. And so what happens is essentially we run some JavaScript commands that build an entire, huge JavaScript file that has all of the extensions inside of it, basically, using the commands in the staging directory. And it pulls all the JavaScript from that extensions directory and pulls all the core extensions in and builds like your JavaScript web application. And every time you install an extension, it has to rebuild this JavaScript application. That's why it takes so long to install an extension. You see the line that says Webpack. That's the thing that's actually assembling the entire application. So that's how sort of JavaScript packaging works, and there's a lot of reasons why we need to do it that way, et cetera. But just be aware that that's sort of what's happening. We're putting the extension in some place, and then we have to build this entire JavaScript application. That's what all those the code, the process lines that are flashing by are, and then you reload JupyterLab, and basically it sends that entire application to your browser again, and your browser starts running it. Okay, questions just at least on a general level about what happens when you install an extension and what that rebuilding step is, et cetera. Yes, good question. Yes, so Node is the thing that's running the JavaScript to build all this stuff, and Node has some memory limits that are pretty low for what we want. And so if you look in the repo instructions, we have some ways to get around that. Where's our repo instructions? If you look at the README and the troubleshooting, if you experience out-of-memory error, there's a couple ways to do it. I found the easiest way to do it is to just define this variable. You can also just pass this option directly in. But then you have to like figure out what the right command is to pass the option into. Essentially what I do is I run this. Okay, so this is actually a new command, JupyterLab build. What JupyterLab build does is it just redoes that building process for you. So it's not installing an extension, it's just sort of rebuilding the application from scratch with the extensions that are already installed. So if you ever have a problem with the extensions, here's what you can do. You can do JupyterLab clean. And what that does is it deletes the application. And you'll notice that the staging directory is now gone. So I've deleted my built bundle. And then you can do JupyterLab build again. And what that does is sort of clean everything out and rebuild the application from scratch to sort of try to reset things. And this will go for a while. This is downloading, just figuring out all the dependencies, it's pulling in the applications, it's deduping all of the dependencies, and the huge dependency tree, and then it's webpacking things, so that's consolidating all of the JavaScript into sort of one file or just a couple of files that are sort of linked together and building your entire application. The other command that is useful to know if you need to reset things is, in a second, you'll be able to do it. The Webpack takes a little while here. This is where we could take a coffee break if you wanted. We do have some logic in JupyterLab to try to understand when an extension has changed, if you're developing an extension or if you install an extension but it hasn't rebuilt. And it sometimes offers to rebuild for you and then reload the page when the rebuild is done. Sometimes it seems like it's a little finicky too, just FYI. Then eventually, this finishes building the application. I mean, it's doing a lot. It's basically assembling a 5, 6, 7, 8 megabyte JavaScript bundle that's sent to your browser here. It's got to parse through all the files. It's got to, if a file requires another file, it has to modify the files so that they can put them in one big, huge JavaScript bundle, et cetera. So one of the commands that you can run is JupyterLab -- core mode. Here it is. Okay, so JupyterLab just works. Right, this is the JupyterLab, and you see my extensions are loaded. Like I have this table of contents extension. I can open up files, et cetera, you know, with the extra extensions. So what I can do is do this, and what this does, the -- core mode, is it says don't use this staging directory. Don't use this JavaScript that you built. Instead, JupyterLab as a Python package comes with pre-built JavaScript, so you don't have to have Node, you don't have to have all these JavaScript building things on your computer. As a Python package, we build all that for you with the core set of plugins, and then we ship that with the Python package. And so you can always fall back to that core JavaScript that was shipped with the Python package using -- core mode. And essentially what this does is all your extensions are gone. Your custom-built JupyterLab with all your extensions is gone, or not gone, but it's not being run here. What's actually being run is the actual original JavaScript that came with your Python package with just the core extensions. And so you'll notice here with this version of JupyterLab, there's not that contents extension, et cetera. So if you ever, this is an equivalent of safe mode. If you ever like get messed up and your extensions are like causing problems, et cetera, and it's not loading, you can run it in -- core mode to fall back to the original JavaScript that came with the Python package without building anything. And it's just running that JavaScript. It's not deleting your other JavaScript. So you can just run JupyterLab again, and it'll pick back up your staging directory. Okay, questions about basic extension management before we go into actually writing our own extension? Okay, so to write your own extension, it's actually just basically a couple dozen lines of code and then a bunch of boilerplate. And the boilerplate we essentially packaged up into using a templating system called Cookie Cutter. And so if you go ahead and open up exercise 5, so let me get somewhere in here. Let's see, which JupyterLab did I open in that directory? Here we are. Oh, sorry, exercise 4. So if you open up exercise 4, and there's some instructions in the Markdown file, and they'll involve running some terminal commands. Go ahead and start, and we can pause halfway through, or we can pause at the end and take a look at sort of the bigger code. What you'll see, maybe I'll just give you a brief heads up. So what you'll see when you generate this cookie cutter is something that looks kind of like this right here. I can make this bigger. I guess I can't make it bigger. Let me pull it over to Chrome. Oh my, that's weird. I don't know why I'm not being able to make it bigger. So what you'll see is like a bunch of directories, a source directory, a style directory, etc. The key file really is the index.ts file inside the source directory. And you see a bunch of JavaScript code in here, or this is actually a superset of JavaScript called TypeScript. It gives basically static typing to JavaScript, and it's what JupyterLab, the language JupyterLab is written in. Essentially JavaScript, but it gives you extra type checking when you compile the TypeScript. And there's a bunch of, here's the import statement for JavaScript. You don't have to pay attention to a lot of this stuff. It's just sort of standard programming where you're declaring a variable, you're setting it equal to this value, etc. What we're going to do is we're going to make something that will pop up a new tab, and it will interpret and render a particular file type. And the end result is a class that essentially has this render method, and this render method is responsible for putting something on the page, so putting something in a new tab. And down here at the very bottom of the file is the boilerplate for registering this with JupyterLab. And so registering it with JupyterLab essentially involves creating a new file type for a particular file type that we're going to create here. It's going to be a file type that has extension .cert.json. It's going to be a JSON file that has just a couple of fields in it. And so when we double click on this .cert.json file in JupyterLab, we want it to come up and sort of render really nicely. And so to register with JupyterLab, we have to tell JupyterLab we have a new file type with this extension. We're going to call this file type certificate file type. And then we're going to register our plugin to be able to handle the certificate file type and say, hey, for our plugin, we need to call this function, which essentially calls this class, and this class renders the stuff. So a lot of boilerplate. Don't worry too much about the boilerplate right now. Instead, the cookie cutter generates all of this for you, and then the instructions walk you through what parts to replace in order to have an extension that renders files of these types. And then the end result is, if you, let's see, I forget if I have my, yeah, there it is. So this file right here, let's open it in an editor, is a JSON file. It's just got 2 data fields in it. And JupyterLab recognizes this .cert.json file and uses that plugin to render that as a nice little HTML thing. So that's the end result. Okay? So go ahead and pull up exercise 4. The first command is running something at the terminal called cookie cutter that creates this new directory, and it'll give you the values to type in for the questions it asks. And then you'll go into the boilerplate command or boilerplate files and replace a few sections here and there. All right. I want to show you some cool things. So we'll probably move on. But I am curious, how many people got to the stage where you had a working extension, not necessarily with the pretty certificate, but with like just the raw text just generated? Congratulations. I think today we've written more JupyterLab extensions than any day in history. That's awesome. Okay. How many people got to the point where you, copied and pasted this HTML code wherever it was down here into the right place and rebuilt and then the CSS and rebuilt it and actually got a certificate? Nice. Good job. Okay. Well, congratulations, everyone. I want to move on after. Is there any big questions from this that we can address? Yeah, so what Matthias, for the camera, what Matthias is saying is when you open a new terminal, this new terminal is not in the SciPy tutorial environment, so you have to explicitly, first thing, conda activate SciPy 18 JLab to get into the environment. Now the JupyterLab build that I do here is the actual JupyterLab inside that environment instead of some other JupyterLab in some other environment, et cetera. So always work inside of this environment when you're doing this. Any other big questions? Okay, so that's the general pattern actually for doing file rendering, and it's more than just file rendering. That same segment of code that just knows how to render things of this particular MIME type works in the notebook too. So here's a notebook. Here's a notebook, and I just made a small little Python class that essentially constructs that MIME type here. And so this is like the IPython display HTML, etc. And now I can just display it here too. And the exact same code runs in the notebook, it runs in the file display, and if anything else in the system wants to be able to render that particular MIME type, then anything else in the system that wants to render rich outputs can use that exact same code to render in their particular environment. So we tried to make this the system very extensible and sort of general and abstract and reusable things. So congratulations to everyone. I know a lot of people made really good progress on it, and we're happy to help you out in other places. I wanted to finish up with a couple of things that are coming up in the next version of JupyterLab. So this is, what you're running is JupyterLab 0.32, which is our second beta release. We are just about to release our third beta release and just give you a taste of sort of what's coming up in the future. Let me make sure I'm running it. So here's the next pre-release. You can install this with pip install -- pre JupyterLab. So a couple of things are an extension manager. So this is a new extension, a core extension, that basically lists the extensions that you have, and it does do some searching. If I just search for space, we have to fix something with the searching. And it actually lists all NPM packages with a particular keyword, JupyterLab extension, that was sort of by convention used for JupyterLab extensions. And so we still have to figure out like how we're going to tell people that these are not our extensions. Don't blame us if they break your computer and run off with your dog or something. But the point is we will have some graphical way of managing extensions, and at least you'll be able to uninstall and disable graphically and see what extensions you have directly inside of JupyterLab. So this is the same guy that wrote the Draw.io plugin. He wrote this in the same week. He's a pretty productive guy. And so it's making its way into core. Another thing, let's see, I got to bring up my list somewhere. Where's my list? Where's our repo? Here we are. Another thing, oh yes, workspaces. Right now JupyterLab doesn't work very well. The version you have doesn't work very well if you open the same JupyterLab into two different windows. Essentially what JupyterLab tries to do, if you open up a bunch of stuff, so let me open up a couple of files, etc., and I layout. If I refresh this window, save, whatever, refresh the window, it opens up the same files in the same layout. Like it really tries to make your workflow so you don't have to reset up everything. And the way it does that is it stores this data, somewhere, and then it brings it back when you open up the browser page. But of course, if you have two tabs open, it doesn't work very well because which tab should we restore? And so what we have is the concept of workspaces. And so if I open up a new tab with this same JupyterLab, in the next version, it comes up and says, wait, you already have a tab open. We want you to give a name to this tab's workspace. And so you type in a second tab or new project, whatever, switch workspace. And you notice the URL is slightly different. Instead of just /lab, it's /lab/workspaces/new project. And what this does is it allows you, and you don't have to open up a new tab to do this. You could just change the URL to use this workspaces URL. What this allows you to do is to have multiple projects open, each with a different layout of your windows, each with different files open, etc., and easily switch between them, easily pick up where you left off. It's a really powerful feature that we have, and it's much more accessible and much more sort of much more accessible in the next version of JupyterLab. So next week when we release the next version of JupyterLab, you'll know what's coming up. Okay. Another thing is that we changed the default behavior of the consoles. So you notice that if you start a new console for this notebook, before, if I press 1+1 up here, then the log appears down in the console. That's handy if you want a log of all your computations, but a lot of people were like, wait, but now the console is not useful because every time I run something, like all the output in my console disappeared. So the default behavior changed so that the console doesn't echo what happened in the notebook. What this allows you to do is to, look at it, if you define a variable up here, then in your console down here, you can plot or whatever and have that plot stay in the same area on page while you keep working in your notebook. You know, 1 minus 5, whatever. If you want to revert back to the previous behavior, then you just right-click, show all kernel activity, and then it starts showing everything that's happening in that kernel. So it's very easy now to switch that console to be just show what I actually executed in that console versus show everything that's going on in the kernel so I can log things. All right, let's see, what else? Oh, yes. Somebody, and so that was a feature that came from a new contributor that came in and said, this workflow makes a lot more sense to me. Here's another feature that came in from a new contributor. Right-click, open a new browser tab. What this does is it opens a new browser. Oh, here my browser's trying to download it. Let me open something that the browser can see better. MD, I don't know. What does the browser understand here? JSON probably, yes. Open a new browser tab. And what this does is it just opens the file in a browser, in a standard browser tab. So it's easy to open an image in a new browser tab, et cetera. Again, this was a new person that came on the list and said, hey, you know, this makes a lot of sense to me. I'd really love to have this feature. And we got them started, or got the person started. And pretty soon they contributed this feature. Let's see. Oh, longer tabs. You'll notice that sometimes your file names get cut off. Finally, it annoyed somebody long enough that they changed the min width and the max width. And now your file names show a little bit better. So many, many upgrades. We upgraded a ton of stuff all through JupyterLab. We upgraded Webpack. We upgraded a lot of dependencies, et cetera. So there's all new, brand new shiny things all over. Some extensions that are in the works. So these aren't in the next version of JupyterLab, but these are being actively worked on by, for example, students at Cal Poly under Brian Granger. Keyboard shortcut editor. Many of you probably would have loved to have that today, where basically it lists the commands and you just click in a box and you type the keyboard shortcut you want and it listens what keys you pressed and that's the shortcut it is, and you're on your way. So a good keyboard shortcut editor is in the works. Status bar. So a status bar at the bottom of JupyterLab that basically anything can talk to and put stuff in that status bar, and you can click on something in the status bar to change a setting, et cetera. We have big plans for the status bar and having a notification API maybe or something like that. And one of the biggest features that's been in the works for a very long time and is progressing is real-time collaboration. So this involves actually a lot of even research level work to enable Google Docs style real-time collaboration with your notebooks and basically any file and any sort of data that you have in JupyterLab. That's a longer term thing. But anyway, lots of exciting things in the pipeline. And we hope that as you got some ideas today, that you come and join us and participate and contribute your exciting ideas and help us to work out whatever sort of remaining UI issues. I know we have a bunch of notes here, but come and contribute your own extensions or write your own extensions and, you know, basically have fun. And really, I think that's the genius of open source is you get to modify the tools for your own use. I'm really excited about seeing what you guys do with this that we never even thought of. Let's see, I guess there's a couple things to mention. JupyterLab works really well in Jupyter Hub. In JupyterLab docs, there's a setup for Jupyter Hub. And the sprints, Saturday and Sunday this weekend, there will be people there that can help out with people that want to sprint and work on a JupyterLab extension or want to help fix some of the dark theme issues or whatever. There'll be people there helping out. And anything else, Matthias? Oh, JupyterCon. Don't forget JupyterCon in August in New York.
JupyterCon is until the 25th, even if most of the dates show 24th, 25th, we will have an open day for anybody who is around. You don't even, well, we'll have registration, but it's going to be free, and come and hang out and work on JupyterCon, on Jupyter, or on projects related to Jupyter. One word about the Jupyter Hub. If you want to deploy or have remote access to Jupyter, you need to use Jupyter Hub. You said you look at Jupyter Hub, but not what it was. So if you have many users, or if you have students, or if you have a lab for 3 person, Jupyter Hub is the thing you need to look at. And I think that's about it. There is a lot of sticky note or red sticky notes around with nothing written on it. there are pens at the end of the tables. Feel free to give us feedback, and we have a few more minutes for questions.
Yeah. Feedback not just on JupyterLab, but feedback on the tutorial as well. We'll be giving more versions of this tutorial at JupyterCon and stuff like that, and we'd love your feedback on pacing or material depth and things like that.
And don't forget, if it works great, it's thanks to you. If something is wrong, it's our fault.
On your launcher, you have multiple languages under the notebook console that we don't. How do you add this?
So when, if I can get your JupyterLab, so if you create that, you basically have many kernels. A kernel is often a language, but not always a language. Is how do you get those? It depends on which language. So basically, for the Python kernel, you need to create for an environment. For example, you would need to. Can I create an environment? So for example, I would do conda create. Oops, maybe zoom in so that you can see what I'm doing. If you do conda create -n foo Python equal 3.7, let's be crazy. It's stable now.
I don't know if you could do this one.
No, yeah, it's on conda forge. So once this environment is created, in this environment I would install IPython kernel. So let's do 3.6. You install IPython kernel, and then you tell IPython kernel install yourself under a specific name, and now you will basically register a kernel with Jupyter, and now everything which is Jupyter enabled will see this kernel, right?
So the thing to Google is how to install a Jupyter kernel for whatever language you're interested in, and that's totally separate from JupyterLab, from Jupyter Notebook. It's part of the decoupling that we have in Jupyter. You install kernels; those are back-end things, and you have front ends, and all the front ends talk to all the kernels. But installing a kernel is a separate issue than the front ends.
Does that make sense? I can finish that. That here you just Google install Jupyter.
Maybe just pull up the wiki page and
list of Jupyter kernel. So if you Google for list of Jupyter kernels, you will have many kernels. Fortran, Ansible is new. Spark, SAS, IPy kernel, Julia, and you will go to, for example, one of this one, IR kernel, and the R kernel will have instruction of, for example, how to install. And it tells you here is how to install, and making the kernel available to Jupyter, you need to, for R, do R IR kernel install spec. And that will basically drop a file somewhere on disk and say, well, here is how to find your kernel. Maybe I can finish that. Python -m IPy kernel dot install.
While Matthias finishes, any other questions?
So regarding JupyterHub deployment, so how do you make sure it's only available locally, like
So I think the question was, how do I secure a Jupyter Hub deployment? And the answer is talk to your system administrator. That totally depends on your network. And there's some very good guides for setting up Jupyter Hub. There's a guide called 0 to Jupyter Hub that walks through the process of setting up a production level Jupyter Hub. But if you're talking about any sort of security things, you really should talk to your network administrator.
And it's not because you install Jupyter or JupyterLab only on your machine that you shouldn't set a password. Because if you don't set a password, any other program on your machine that have network access could run code on your machine via Jupyter. So always set a password on your installation, even if they are local.
Other questions?
Yeah, the workspaces.
Yeah.
Are those persistent between sessions?
Workspaces are saved to your disk. If you type JupyterLab path, like we saw the staging directory, then you'll see one of the directories is a settings directory. And so basically what happens is JupyterLab talks to the Jupyter Notebook server and communicates the settings, and the Jupyter Notebook server has a special extension that saves those settings to disk. So yes, those are persisted. And if you type JupyterLab path, you'll see where they're persisted to.
there is one issue with NB-conda, that it works only with the thing where you install the extension. So one other thing we discovered is that if you have NB-conda, it would work with Jupyter Notebook and JupyterLab. But as soon as you use Jupyter NB-convert command line, or if you use something like interact, or you use hydrogen, then NB-conda will not be seen. And that leads to frustration with users, which is one of the reasons why we actually want to drop things on disk. So there are some discussions. We are not sure exactly what the solution will be, so we are not going to say anything.
I think we have time for maybe one more.
Is there any plan for implementing the debugger? Like
Ha!
debugger with breakpoints and
Yes.
sharp style?
Oh, our favorite pet subject. Question is a debugger. Yes, lots of plans, in fact. The problem with the debugger is that it requires deeper level support in the Jupyter messaging protocol for dealing with debugging messages back and forth to a kernel. So here is a repo that starts talking by a guy that's written several Python debuggers, like these people know what they're talking about what a Jupyter debugging protocol would look like. And once that sort of messaging layer is in place, we can build a UI on top of that. That said, there are people that are working on variable inspectors to have just a watch list of variables. You know, that takes you a long ways. There is command line debugging already using PDB. So it works like in the classic notebook where you can use %PDB and you can step through with the command line. So there's various solutions that get you a lot of the way there. To do a really proper debugger support, we need a protocol, and there's active discussions going on about a protocol. So we invite you to join the discussion. All right, thank you everyone, and feel free to contact us, during the conference or any of the people that were helping out during the conference, and yeah, give us any feedback. We appreciate it, and have a wonderful conference.